Oh, hi. Thanks for showing up for your learning. Let's take a look at how we tackle our exponent rules questions. In these ones, we just look at it k times k to the 3. Oh, that's k multiplied by itself 4 times. To write an exponent, you're going to push shift 6, and that lifts your cursor up, and then you can put in your answer. There you go. So then these questions will test your abilities just with the basic exponent laws. So here x squared to the 6 is going to be multiply the exponents. So that's x to the 12. Right. M to the also 12, because 4 times 3 is also 12. Right. And then this one, again, we're going to be adding exponents when we're multiplying powers of the same base. So this is b to the 4 plus 5, or b to the 9. And let's see if it will give us one where we're dividing. No, it's not. It's being very stubborn. Anyway, we'll get those in just a moment. These ones down here are full of more challenging ones. And if you can get through these, it's fantastic. Let's take a look at how you will tackle them on a whiteboard. So here I have 6x to the 4 y to the 4 multiplied by 8x to the 3 y to the 2. And multiplication can be done in any order. So this could also be written as 6 times 8 times x to the 4 times x to the 3 times y to the 4 times y to the 2. 6 times 8, that's just 48. X to the 4 times x to the 3, that's just x to the 7. Y to the 4, y to the 2, that's just y to the 6. So there's an answer. 48 x to the 7, y to the 6. Yeah. New one. So here, same idea. I could write this out as negative 10 multiplied by negative 3, x to the 5 multiplied by x to the 4, y to the 2 multiplied by y to the 4. And then just total them up. That's going to be x to the 9, that's going to be x to the 6, and that's going to be positive 30. Ta-da. So when we're raising powers to powers, here we're going to use the same idea as just apply our exponent laws, but to all of the little bits that are in there. So these are too janky and too big to write out repeatedly, so you're going to want to be able to apply your laws. If I have negative 5, x to the 5, y to the 2 to the 5, I'm going to remember these laws. A times b to the c is equal to a to the c, b to the c. And another law, if I have x to the a and I raise that to the b, then I multiply exponents, x to the ab. So let's apply that idea. All right, first, let's just make this big so we don't need the rest of the stuff. So here I can write this as negative 5 to the 5, x to the 5 times 5, and y to the 2 times 5. So I'm going to multiply this exponent here. I'm going to multiply that exponent there, and I'm going to raise that number to the power 5. Okay, so let's see. Negative 5 to the 5, that is going to be negative because there is a negative number. Sorry, there's an odd number of negatives. There's 5 negatives there, so it's going to be back to negative. And 5 to the 5 happens to be 325. 3,125, he says, does not have it memorized. He has to work it out. And then x to the 25, because 5 times 5 is 25, y to the 10. X to the 25, y to the 10. You can absolutely get exponents that are that big, like to the 25 and stuff, particularly in financial math problems. Much bigger than that. Let's keep going. Negative 6, x to the 4, y, all to the 3. And so negative 6 to the 3 is still going to be negative because 3 is odd. And that's going to be negative 216 because 6 to the 3 is 216. X to the 4 to the 3, multiply the exponents to get x to the 12. And then y to the 1 to the 3 is going to be y to the 3. This is how these are done. This one here, negative 6 squared, is going to be positive 36 because that's an even number of negatives. X to the 3 to the 2 is x to the 6. And y to the 4 to the 2 is y to the 8. Why is my y capital? Oh, it liked it anyway. Okay, cool. So that's how those are done. Now let's take a look at dividing powers. We're going to use our quotient of a power law. All right, let's rock out on some of these problems here. So in these cases, we want to fully simplify, and the numbers, you're basically reducing fractions. So here, 18, x to the 7, y to the 5, all divided by 30, x, y to the 4. Let's go. So in these cases, we can write this as like 18 over 30. Just deal with the numbers separately. X to the 7 divided by x to the 1 is going to be x to the 7 minus 1. And y to the 5 divided by y to the 4 is going to be y to the 5 minus 4. So that's one simplification. 18 over 30 is a fancy way of saying 3 over 5, because both of those have the lowest common factor is 6. So I can divide, the greatest common factor is 6, so I can divide that out to give me 3 over 5. 18 is 3 times 6, and 30 is 5 times 6. And 3 and 5 don't share factors. If I can't see that or find it right away, I can go 18 is 2 and 9 and 3 and 3. And then I can also do 30 is 2 and 15 and 3 and 5. So this is the common part, 2 and 3. That's the part that will come out. And this is what's left, the leftovers, 3 and 5. So that's x to the 6, y to the 1. So let's write it out. So I go 3 over 5, and I want to write my x's on top. X to the 6, y to the 1. There. Submit answer. Hooray. Keep going. All right. 4 over 2 is a fancy way of saying 2. X to the 4 divided by x to the 8. Actually, the x is going to end up on the bottom. X to the 4. Okay. And then the y to the 7 over y to the 7. That's just 1. So I just submit the answer. Yes. And if you get one like this that's confusing, you can look at it like this. So here, this is their method, which is very similar to the way we can think about it. All right, is expand it with multiplication. X to the 8 could be written as x to the 4 multiplied by x to the 4. And then once you know that, then you see there's 1x to the 4 on top and 2x to the 4 is on the bottom. So just there's 1x to the 4 left on the bottom. And they wanted you to think about it like simplify the numbers, simplify the x's, and simplify the y's all separately. Boop, 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 there it is. Okay, let's look at another one. New problem. Okay, 125 divided by 25 happens to be 5. X to the 7 divided by x to the 8 will leave 1x on the bottom. If you used your exponent laws, this is what you would get. You would be right, but you would have an extra step to do. 125 over 25 there. X to the 7 over x to the 8. Y to the 5 over y to the 7. So anyways, just purely apply your exponent laws. That's 5 to the 3 divided by 5 squared. That's one way of thinking about these numbers. All right. And then x to the 7 minus 8, y to the 5 minus 7. Okay, let's do it. These two x's will cancel two of those x's up there. Just leave me 5. X to the 7 minus 8 is x to the minus 1. And y to the 5 minus 7 is y to the minus 2. Let's go write that in and see what Delta Math says. Submit answer. Am I sure? Yes. Oh, it didn't like it. It's actually correct, but it doesn't like it. And the reason is, it said, please just use positive exponents. So when you want to convert these negative exponents, your answer is not fully simplified or not in the correct form, okay? See, those negative exponents want to kick those numbers down to the bottom of the fraction. And then they're positive exponents. So that's one way you can do that. That's applying your negative exponent laws that we discovered yesterday. If you have something like x to the negative 1, that's equal to 1 over x. There's a positive exponent. If you had x to the negative 2, that would be 1 over x squared. And if you had x to the negative a, that would be 1 over x to the a. There's the rule. Okay. It looks like alphabet soup, but it's the most general rule for that type of thing. So let's look at a very specific one. If I have, oops, my pen is upside down, 2 to the negative 2. Well, I could write that as 1 over 2 squared, or that should be equal to 1/4. Let's check my calculator and see if that's true. Oops, that's my calendar. This is my calculator. Oh my goodness, we're so popular. Okay, let's keep going. Let's do a couple of these and be successful. All right, so if I have 27 x to the 4 y to the 3 over x to the 8 y, then I can see that there's going to be an x to the 4 left on the bottom. The 27 is still going to be on the top, and there's going to be 1 y squared on the top. So it's just going to be y squared. Y to the 3 minus 1, all divided by x to the 4. That's how these are done. Okay, and then there's 24 divided by 8 is just 3. X to the 6 divided by x to the 4 is just x squared. And y to the 6 divided by y to the 8 will leave a y to the 2 on the bottom. There you go. So now last one are mixed power problems. And here we go, right away. It gives us this one. I can't take this problem type out for you, and all the other problem types are useful. But we just went over some examples like this. Let's take a look. These are a big deal in grade 10. So with these ones, what you're going to want to do is write them out on a whiteboard, or just skip it and try a different problem. You can skip it and try a different problem at this level, that's okay. But if you want to learn how to do these, write it out as squaring it. And here's the thing you'll learn about in grade 10. If I have what we call a binomial multiplying another binomial, a binomial is a thing with two terms, and we're going to study these in Unit 3. But we're not going to do exactly what we're seeing here. But I might make you do it anyway because it's just so useful for grade 10. 2x, and then what I want to do is I want to make sure that this first term here, the 2x to the 3, multiplies both of those things in the other bracket. So that's going to be 2x to the 3 times 2x to the 3 is 4, because 2 times 2 is 4, and x to the 3 times x to the 3 is x to the 6. 2x to the 3 times negative y to the 5, so I can consider the sign as well. That's going to be negative 2, x to the 3, y to the 5. And then I do the same thing for this bit here. It's going to multiply both of these in that bracket. So the negative y to the 5 times 2x to the 3 is going to be negative 2, x to the 3, y to the 5. Oh, look, there's 2 times the first term times the second term. That's why we have 2ab in there. Okay. And then negative y to the 5 times negative y to the 5. That's a negative times a negative, so that's going to be positive y to the 10. Okay. These is like these two in here are the same thing. They're both x squared, x cubed, y to the 5s, so they can actually be added together. Here I have negative 2 of them, and there I have negative 2 of them, so altogether I have negative 4 of them. 4x to the 6 minus 4x to the 3, y to the 5, plus y to the 10. Put that in, that's the answer. Good. Let's go new problem. Hooray! These are the mixed power problems that I'm looking for to get you to do. And these ones are just the laws that you have. 6 to the 5 is really big, so I might just evaluate that on a calculator. I might go 6 to the 5 is equal to 7776. I feel like I've calculated that at some point in the past. 7776 multiplied by x to the 5, y to the 10. Oh, and I forgot to lower my cursor. Hooray! And so that's those types of problems. Any questions, send me an email. A screenshot's really useful. You can go like, I don't understand what they're saying here. And then you send me this screenshot and you're like, please explain. I might even send you a video answer. Okay, otherwise, thanks for showing up for your learning. Bye for now.